Hello everyone, day 2 of vectors. Let's get into it. Oh, that is still yellow. My bad. There we go. Now we can get into it, sorry. Vectors. Day 2. And we're gonna start with adding and subtracting with vectors. So I am going to show you how to do this visually, but I'm really going to be concerned with the algebraic piece, which I think might be a little bit easier. So we're going to say you're given two vectors. Vector u is 5, 2, so this is already in standard position. And vector v is negative 1, 3. So on a graph, it's going to look something like this. Let's make sure I'm giving myself enough space. Never, ever is it a straight line. Okay. So let's see. Vector u, 1, 2, 3, 4, 5, 2 is going to be here. This one here, this is vector u. And then vector v, negative 1, 3. That's right there, that is vector v. So if I want to find vector u plus vector v, what I'm going to do visually is connect my initial point of my vector v to my terminal point, or kind of like the arrow of vector u, then connect the third side. Now when I say third side, what does that really mean? Well, I'm going to take this vector u, I'll do this in blue, and I'm going to kind of move it over so that it starts here, but it still has to have the same, it has to be equivalent. It has to have the same direction and magnitude. So it's now going to look like this. So this is my new vector v right here. I have connected my initial point of v to my terminal point of u. And then when it says connect the third side, means I'm going to start here at my initial point of u and connect that to my terminal point of v. So this red vector right here, this is the vector of u plus v. So that's all you do. So you're just moving it along, moving it to the side. But if I was to do this algebraically, I might say that, okay, vector u plus vector v. Let's see, I know vector u is 5, 2. And vector v is negative 1, 3. And now I'm just going to add like parts. So I'm going to say, hey, this is going to be 5 plus negative 1. So I'm adding my x values together. And then 2 plus 3. And I'm adding my y values together. So I get that vector u plus vector v is 4, 5. So that is going to be my x and my y. And if you take a look at the visual piece right here, we notice that our terminal point of our vector u plus v is in fact 4, 5. So that's all you do. Now, subtracting is pretty similar, and you can probably guess how to do that, but visually it takes it's slightly different, so I am going to show you how to do that as well. I'm going to move this up, but I am going to still be using the same u and v vector. Okay, let's get this moved. I think I'm just going to rewrite that for us so that we know. Oops. Oh, that is still in red. My bad. Let's see. Vector u is 5, 2, and vector v is negative 1, 3. So I'm going to regraph that for us. So let's see. Here's our vector v. Here's our vector u. And we want to find now, we're going to do u minus v. Now, when we're subtracting visually, I've talked about negative vectors like very slightly. It just goes in the opposite direction, or essentially pointing down. And since we already know how to add vectors together, I'm just going to turn this into an addition problem by saying this is vector u plus a negative vector v. So what I'm going to do is I'm going to essentially turn this around. So I'm still going to connect my terminal, or pardon me, my initial point of v to my terminal point of u. So that's still going to start right here. But instead of going up 3 and to the left one, I'm going to go down 3 and to the right one. And so this is what negative v will look like. So it's just going in the other direction. And then in order to find my answer, I'm still going to connect my initial point of u to my terminal point of now negative v. So this is going to be u minus v. So that's what that looks like. So again, just remind yourself that negative v is v with an opposite direction. Now, if you were to do this algebraically, you can just leave it as a subtraction. You can turn it into a plus a negative. You can do this any way that you want. So if we're going to do algebraically, vector u minus vector v, it's going to be 5, 2 minus negative 1, 3. And you know what? I'm just going to keep this as minus. So this is going to be 5 minus a negative 1, comma, 2 minus 3. And that's going to leave us with 6, negative 1. And you will notice this is, in fact, the x and y value of our new vector. That is 6. Well, I figured out that I accidentally muted myself. My bad. So there's probably a weird, awkward silence there. I went back and edited that. That is our new x and y value. The last algebraic piece we're going to do is scaling, which is essentially multiplying. I'm not going to show it to you visually, but just know that it's essentially extending the length by whatever scale you are using. I'm doing kind of scaling quotes right now. So we'll do a real quick one for you, and then show you how you can combine all of this together. So we're going to still be using the same vectors u and v. So what if I wanted to do, let's see, is this still in black? This is in red. Okay. Really quick scaling. What if I wanted to do 4u? So 4 vector u, what would that be? Well, that would essentially be 4 times our vector 5 and 2. All I'm going to do is take that 4, essentially distribute it to my x and y values, giving it that scaling. Whoops. And this becomes 28. That is it. That's all you have to do for scaling. So now let's take a moment and let's try putting all of this together. So what if I wanted to find, let's see, 3u minus 2v. What would that look like? Well, that's going to be 3 times 5 comma 2 minus 2 times negative 1 comma 3. So first thing I'm going to do, order of operations, I got to do my multiplying, figure out my scaling. So I'm going to multiply this 3 in here. And then when I multiply in the 2 for my vector v, I can multiply in -2 if I want and turn this into an addition problem, or I can just multiply in the 2 and leave it as a subtraction problem. So I think I'm just going to multiply the 2 in, and that's going to give 15, 6 minus -2, also 6. And then from here, we're going to subtract like pieces. So our x's from our x's, our y's from our y's. So this will be 15 minus, oops, I don't know what happened there, a -2 comma 6 minus 6. So for our final answer here, we're going to get 17 comma 0. And that's it. So that's what that looks like when we are combining our adding, subtracting, and our scaling. But what if now I also wanted to ask for the magnitude? Because this is just a vector within itself. I can still ask for the magnitude of this. So if I went, hey, what is the magnitude or length of 3u minus 2v, I'm still just going to use my x and my y here and find that. So this is going to be equal to the square root of 17 squared plus 0 squared, or the square root of 17 squared. Now I can figure this out, but also square and square roots cancel each other out and I just get 17. So I can say that the magnitude of 3u minus 2v is 17. So we can still use all the previous information, or all the previous knowledge from our other video and apply it here as well. So this is kind of all the algebraic pieces. Last step I want to do is something I promised you last video, which is about direction. Finding direction of a vector. How do we do that? We already knew magnitude, so let's start our next piece. And I promise this will probably be faster than you think it is. So let's move this up. So if I want to do, oh, why does that keep happening? I know you can't see, but all these other options keep popping up. Okay, so let's make this prettier. There we go. Direction, angle of a vector. So the direction is really what angle is the vector at, because how big or small the angle is can kind of help lean our vector in a specific way. So right now let's pick a vector v. We say that vector v is 3, 4. This is our vector. Now again, I'm not going to have you draw unless it's something that helps you, but I'm just showing this to you visually just so you can see what's going on. So let's see, vector 3, 4, 3, 4, there we go. Okay, so this is going to be vector v, and let's see, we know this length right here, that's 3. Length here is 4. And what I am asking for is this angle, we're going to call it alpha. We're asking for this angle right here. And I look at this and I go, this seems to be a right triangle. So if this is my vector and this is a right triangle, I know my opposite side and my adjacent side looks like I'm going to be using tangent. So if I want to find what this angle is, I'm going to say that tangent of alpha is equal to opposite over adjacent. In order to get alpha by itself, I'm going to use tangent inverse on both sides. And then I'm going to plug this in my calculator, and I get alpha. I'm going to round this to the second decimal place. If you round it to the first, that's okay. Alpha is equal to 53.13 degrees. And that is what we consider the direction. If it was smaller, something like 20 degrees, that's going to lean more to the right versus if it's an obtuse angle. But this is it. This is the answer I'm looking for. And that's what we want for direction. So let's try it again. What if I didn't give you a visual picture? So what if I said, for practice, I'm going to give you 2 practice problems, then we'll be done. So what if I said that vector u was 3, 2. Okay, well, let's see. 3 is my x value. That's going to be my cosine. You can think of it that way. 2 is going to be my y value, or my sine. I know tangent is sine over cosine, or x over y. So I'm going to say that tangent of alpha, or my angle, is going to be 2 over 3. I'm going to use tangent inverse on both sides. Plug that into my calculator, and I get alpha is 33.69 degrees. And there you go. I'm done. Now you might be thinking, Miss Twain, this is too obvious. There must be more than this. Well, yes, of course there is. There's like 1,012 more things I can teach you about vectors. There's so much interesting stuff. It's very much applicable to real life world. But I am going to go just slightly deeper into direction right now. Because both the examples I've given you at this point deal with the first quadrant. But what if it doesn't? So I'm going to move this up, show you one more example, and we'll be done. So let's see, I'm going to give you, I'm going to say that vector v is -5, 4. So negative x value, positive y value, that's going to leave me in the second quadrant. So should be good there. Did not leave myself enough space. Okay, -5, 1, 2, 3, 4. Okay, so that's like there. There's my vector v. Now what I need to find is this right here. So I'm just going to do what we've been doing so far. So let's see, that'll be tangent of alpha is equal to my y value over my x value, or alpha is equal to tangent inverse, -4 over 5. Now when I plug that in my calculator, I get -38.66 degrees. And that makes no sense at all, because that is going to be in quadrant 4 in our negative direction. So that's really kind of coming over here. And we know that this is not the direction that we want our vector v to go. And we already drew vector v. We know that's not correct. And I should draw that in red just so we can see. So what I need to do is I need to take this, there we go. I need to take this and somehow bring it all the way over here, and you'll notice I've drawn a line. So if I get something over here in quadrant 4 when it's supposed to be in quadrant 2, I know from previous experience that tangent is always half of a unit circle away, it's pi away, or 180 degrees. So in this specific example, I'm going to take -38.66, add 180 degrees, and get 141.34 degrees. So my answer for this problem is not -38.66. It's going to be alpha is equal to 141.34 degrees. And this makes sense because we know that this angle right here is an obtuse angle. It has to be greater than 90 degrees, as this one is. So you may see a problem like this in the homework. I haven't decided yet, but you will definitely be finding direction angles for vectors. I think this is the last video that I'm going to be making for this year, possibly. I'll be taking a look. I just want to say thank you for listening to all of the videos. I very much appreciate it. Make sure you keep on learning.